Okay, good morning, one and all, and welcome to the GQRP convention. Very warm welcome, not only to the GQRP convention, but to the 50th anniversary convention. We're celebrating 50 years of GQRP. It was in September 1974 that George Dobbs said, wouldn't it be a good idea to have a QRP club? So literally 50 years ago, about this week, George was cooking up a club. And here we are 50 years later with 4,000 members, which is a fantastic achievement. We've had a 50th anniversary card from the Benelux QRP Club. So thanks to the fine people over in Belgium, Netherlands and Luxembourg, which was very nice of them to send that. Robert, who's the chairman, would have been here, but he's not been very well. Good news is he's in the road to recovery and he hopes to be here next year. So that's all good. I'm not going to waffle on any further. I'm going to hand you over to Hans, who's going to tell us about his kits, and I'll let him introduce himself rather than steal his sandwiches.
Thank you, Steve. So yeah, it's the 50th year anniversary, so I wanted to talk about that in a moment. Steve asked me just to give an overview of the QRP Labs kits and how we got started, where we came from, what we've got now, the latest thing. I've got quite a few slides, so I have to go through it quite quickly. But I will put the slides, I think, on my webpage or maybe on the GQRP Club later, and we can look at that. So starting off, this is a picture of me presenting in 2006 in the Rochdale mini convention. I don't know if any of you remember or were there. George used to have the mini convention in the church hall at Rochdale and the presentations in the church. So it's an amazing venue to speak at. And I was talking about some of my homebrew stuff. Of course, I hadn't imagined ever selling kits at that point. So I was just talking about my homebrew things. And then one of the highlights, of course, was a group of people who went back to George's vicarage after the main event in the evening and had food and good conversation. And this is my station here, my homebrew station, all set up and in George's shack, connect to his antenna, and I had some QSOs later that you can see there on the right. There is dear George at his shack with my transceiver there. So happy days. I wanted to start off with that because this is the 50th anniversary. I've been a member for, I think, just over 30 years, so feeling old now. So short history, how we got started. It all went back to 2010 when I was into this very slow signal modes, QRSS modes, which is basically morphs sent very, very slowly. And my friend Steve G0UPL, who is not here today, unfortunately, he suggested, why don't we make a kit? So he made 100 of these tiny boards and sold them for $15 each, which was about £10 at the time, after the talk which I did at EFTIM. And they turned out to be tremendously popular. I had no idea about vendor evening, and George said, come and sit down on my GQRP Club table, and you can use that for preparing your kits. So this was actually George's table at the GQRP Club table, and you can see it was empty there. And George is nowhere to be seen. He was a little bit upset about I wouldn't say envious, because, he was as a member of the church, he was not allowed to, one of the 7 sins. But, I had my pile up stretching back there, and the kits turned out to be so popular that Steve and I decided to continue with it and start evolving it. And the next thing I did was this standalone whisper beacon. It was the first standalone whisper beacon. Up until then, people had a big SSB transceiver and they had a computer generating the whisper. And this was the first time it was done standalone. So it was a really nice kit, and we sold that for, I think, £15 or something, very low cost. It also did all these other modes, and you could configure it. There are these 2 buttons here, so you could configure your own call sign and what you wanted to operate. And it really sort of started the thing off getting more complex software. And the kits really got really popular quickly, and it was a big surprise. But it was still a very small operation, and we were not really taking it seriously. And Steve, his father was very elderly, and so he sort of stopped doing it. So I continued on my own really from 2013. And then at that time I was living in Japan. So I spent 5.5 years in Tokyo working at a software at a bank in Tokyo. And Tokyo apartments are very small. And we saw the apartment we were going to rent, and it had this walk-in bedroom wardrobe. And I said to my wife, right, that's perfect for my shack, you know. And it was literally 5 by 4 feet. And I put this tiny IKEA desk in there and all my equipment, and I could go in there and I could close the door and it was very cozy and do my stuff. So that was where I started doing everything in the early days. So it wasn't even a garage, you know, it was like bedroom closet, walk-in wardrobe. There's some other pictures of it. And this was a picture of the test equipment I had in those days. My spectrum analyzer I'm still using now, old Heathkit frequency counter. Saw one of these outside on one of the stalls today. Very nice frequency counter. And then that evolved into the Ultimate 2 QRSS Whisper beacon kit, which used this DDS module for a much wider frequency coverage and plug-in band modules. So it was some advances there. Eventually, I evolved that into Ultimate 3S, which had this LCD module, which you could address with 4-bit addressing. And there were then spare I/O pins from the microcontroller to switch relays. So that became a 6-band relay switched transmitter beacon kit for Whisper and QRSS modes. Then in 2014, those black market DDS modules from China all dried up. The black market was empty. And so I had to change to this 5351A chip, which was suggested by John G0UPL of SDRkits.net, a good friend of mine. So he suggested that chip. And that became the center of everything that I did after that, all the transceivers, amazing little chip. I also started designing these enclosures for it, and a lot of it was driven by customer demand, and people suggested you could produce an enclosure and that would be popular and make things easier. And all the time, I was learning as I went about the electronics, the software, how to do manufacturing. This comes out a little bit different on here. Some of the writing is overlapped, different to my computer at home, but anyway, you get the idea. There was a whole load of extra modules that I started developing that would add on to that, like the receiver and the module and an amplifier, a 5-watt amplifier module. It also generated a whole number of spin-off kits, such as the clock kit and a GPS kit. People had connected lots of different GPS modules, and they always had trouble with what pull-up resistors to use, and did it have a 5-volt regulator or not? And it was always a mess. So I designed a module that people could be then sure of. Another project I started in 2015 with David VE3KCL in Toronto was this balloon tracker, which is a really tiny, it's about 3 centimeters by 13 millimeters. And you snap off this USB connect bit and it weighs only 1.8 grams. And you can use that for balloon tracking, high altitude balloon tracking. A high altitude balloon tracking with latex balloons can be a very expensive business with big 2, 3, 4 meter balloons, a lot of helium. They can carry about 1/4 kilogram of weight, and they typically go up, burst, and come down. Whereas this is suitable for the kind of birthday balloon, which is a mylar film, and it doesn't expand. So it goes up, and if you get it right, it reaches an altitude, and then it stays at that altitude and floats. And some people have had balloons that have stayed flying for 2 years, and they've been around the world, 100 times in that time. Our record with this was 10.5 months, and it went around the world 18 times in that time. So, and it gives a report every 10 minutes via Whisper with only 27 milliwatts. So it's a really fun project. There it is in a normal dessert spoon. So it gives another view of the size. Well, yeah, that's an interesting question. The one that was shot down over Alaska was apparently a university, not this, but a university project, similar project. We know that one of these was flying above Romania, and the Romanian Air Force got nervous, and they sent 2 MiG jets to find it and shoot it down, and they couldn't find it. It was too small. But we know from the position where this is that it was one of these. But they were using a transparent balloon, and they just couldn't get a visual contact on it, and it was too small for the radar. So the radar they had on the aircraft. This is an example of the tracking map that you get, and it updates every 10 minutes real time. Another project I had was a simple microcontroller project around the 5351A synthesizer chip. And I made now a very miniature version which sits inside an HD6 crystal. So you can see this is the HD6 crystal case, and you can fit it inside. And so it's not an exact replacement for a crystal because it has a 3.3 volt square wave output, but it's configurable with a USB connection. There's a micro USB card there, and it can actually produce 3 different frequencies in parallel, 8 banks of frequencies you can select. There's a very nice sort of miniature controller. Then came 2017 and the first transceiver kit that I made, which was the QCX. And QCX single band analog transceiver, and it was actually started for the RSGB when they had a why you look like that? They had in 2017 the summer YOTA summer camp, youngsters on the air, a summer camp. It was hosted by the RSGB, and they were looking for kit suggestions. And they sent an email out and they said, we've got a budget of £1,000 and we've got 78 people coming. And I was dividing it all out and converting it to dollars because all my costs are in dollars, and it was $16 per person. And I just laughed and deleted the email. And then later that evening, my mind kept coming back to it. What could you do for $16? And I came back and I started thinking, what if you subsidized it and you made 500 and you sold the rest for a profit? And I started thinking of all of this, what you could build. And I didn't want to build something very trivial like a one transmitter, or because they were youngsters and many of them had not done CW. And I think if you've got newcomers, you can actually be too simple and you can make it hard to use. That can put them off. You need something that has got a reasonable performance, reasonable feature set that really you can use as a radio, as well as being low cost. So this was what I came up with, and I undeleted the email same evening, wrote back my proposal, and then started thinking about the design that night. I was lying in bed awake thinking about design, and started building it the Monday morning. And a week later, I had my first QSO. I think that's on here. This was the prototype, all on ugly style. And I actually used the front panel of the Ultimate 3S and the processor behind it as the processor, and just everything hardwired up. And so had my first QSO 13 days later, and the basic design was done in that time. But it took then another 2 months for the RSGB to make their decision about, their committee meetings and whatever they do, and decided to go ahead with it. And so it was a huge rush to get it finished in time for the August build-a-thon and produce the kits and source all the parts. And it's basically very similar to the NorCal 2030 with a down conversion to baseband. Very good performance and easy to build. This is a circuit diagram of the quadrature sampling detector section that ends up with baseband I and Q signals. The 5351A, I mentioned this digital phase lock loop chip. It costs less than $1. In fact, there's now a Chinese version which costs about 60 cents. And it produces 3 outputs anywhere from 3.5 kilohertz to 200 megahertz with incredible fine resolution, all configured by a serial port I2C bus. Serious device, also used in the Elecraft KX2. So real companies use it as well, And so it's a really useful device. I also used a Class E power amplifier, and the reason for that was I didn't want to have a heatsink, and I wanted the thing to stay on the 10 by 8 centimeter board because I was using Eagle as my PCB tool, and the free version of Eagle was limited to 80 square centimeters. Now I have a license and all of it properly, but in those days, and the BS170s were very cheap, and it's very high efficiency. And I'd never had a Class E that worked before. It was the first time I'd managed to make it work. So then the microcontroller, so it was an analog radio, but the microcontroller was really in charge of everything. And as much functionality as I could, I took out of hardware and put it in the microcontroller. So for example, the side tone generation, the keyer, everything was in that microcontroller. Split VFOs, S-meter, there's a battery voltage on the screen, memories, preset memories, frequency memories, the CW decoder in there as well. So it was a real feature set packed into that very inexpensive microcontroller. Another really nice feature, and I had visions of the RSGB with their build-a-thon and all these youngsters building, and there would probably be only 1 or 2 guys running around like headless chicken trying to help fix all the problems. And a lot of transceiver, you build the kit and it says, you know, fire up a signal generator and or tune to a strong signal or different things. And I thought with this, I will try to put as much as possible inside the radio, its own built-in test tools. And so it's got all its own tools for alignment and injecting a signal in the front end, which really make it easy to build and set up. And that was quite unique in such a low-cost kit at that time. And then the bonus feature, I put in the Whisper again. It was ported from my earlier code for the Ultimate 3S. So that was kind of a bonus feature in the QCX. That's a block diagram, probably a bit small to see from here, but then there was a third-party enclosure that was made by a German company. One of the faults of my original QCX was that the mechanical design was poor. And when you looked at the heights of the controls and the connectors were on the side, the LCD, the rotary encoder, the volume control, they're all at different heights, and it made it very hard to put in an enclosure. I wasn't a mechanical engineer, I wasn't an electronic engineer or software engineer either, but I was learning everything as I went, and I hadn't got as far as learning mechanical stuff yet. So it was a fail on mechanical design. But this Bamatech company managed to make a enclosure with extensions for the shafts and sold that from Germany. There were lots of software enhancements, as I mentioned before, all user-driven. People wanted new things, so there was ongoing software. The chip only has 32K of flash memory, so it was always a struggle to fit more in. And I was always having to find ways of deleting things and making it more compact to be able to put more things in. And then after a while, I decided to fix all that mechanical defects in the design and came out with the QCX Plus, which is the version we still sell today, which has this nice extruded aluminium enclosure and a lot of space inside to make modifications. At the same time, added a TCXO option, which made it very, very precise for Whisper operations, and an AGC module, because AGC had been missing from the original design. Some people had wanted that. Some people said you don't need AGC with CW, but we made the module, so it was there. Picture of the rear panel, the connectors neatly on one panel there at the rear. That's the picture of the TCXO, optional TCXO module and the optional AGC module. We also at that point started an assembly service. So the people who were too old or too shaky or too lazy or too rich, they could buy a built radio from us that was built and tested for an extra fee. And that has been so popular that we now have we actually have 13 people employed now at our office in Turkey where I live. And most of those people are doing assembly and testing of assembled radios. It takes maybe 2 or 3 people to handle the shipping and the kitting, and the rest of them are doing the assembly. So it became a big thing. It also was nice from my perspective because it gave a certain critical mass to the business, so that if people left or new people came or something needed to be done, it's largely that they can teach each other. The existing ones who've been with us for a few years can teach the newcomers. So it was nice from that perspective. And then when I released that QCX Plus, some people said, that's bigger than the Q6 and we don't like it, it's not as portable. You should bring back the Q6 and sell them both. But I didn't like going backwards. So I said, okay, I'll make a miniature version. And that was the QCX Mini that you see there. Very nice, very small. It's 63 millimeters by 25 millimeters deep and 92 millimeters wide. So it's a very, very compact. Now, as of now, we've sold almost 21,000 of the QCX series transceivers from the original, the Plus. And so it's been quite a ride. And I never, ever expected when RSGB, I was thinking I make 500. I tried to make enough money to cover the ones I sent to RSGB and subsidize that from the other 500. I never imagined in my wildest dreams that I'd be standing here a few years later having made 21,000 of them. It does keep me out of mischief. And so that's the 3 QCX, the original one in the Bamatech case in the middle and the Mini and the Plus on the right. The photograph is bad. It is actually very much smaller, but it looks bigger there, I think, from the angle. And then I also made a 50-watt power amplifier to go, oh, sorry, this is QRP. Oh, I'm sorry. And that's been very popular as well. I won't say anything more about that.
You haven't told you about the 500.
Well, funny enough. So in 2021, there were these various Digimode transceivers coming up that did FT8. Everyone loves FT8. But there were various Digimode transceivers, and I didn't like any of the ones. There were three that I won't mention names, but three kits that were available. And I decided I would make a kit called QDX, which would completely blast everybody else's performance and features and at the same price. So that was QDX, and it's in this tiny box, which is a bit smaller than a QCX Mini, but it includes USB sound card, and it includes cat control, 5-watt power output, and with 5 bands or 6 bands. So we have an 80 to 20 meter version and a 20 to 10 meter version, depending on what low pass filter you use. It has a very high performance SDR. So this was the first time I did an SDR transceiver kit in production. And really SDR is a whole nother topic, but it was clear to me that it would be that the QCX was the last analog transceiver kit that I would produce as a product. A homebrew is different, but when you do SDR, it gives you so much more performance and features for the price that it's perfect for a product. And then you can introduce more features by firmware updates as you go. It was also where I started this whole use of 1N4007 diodes as pin diode switching for transmit receive switching, which is much nicer than using relays, as well as more compact and cheaper to produce. That's a picture of the inside, and you can see there's quite a lot of SMD components. In common with all the other kits that we produce now, they are done in a factory, so there's no SMD to do by hand when you build the kit, just toys and connectors. I came up with a unique way of transmitting the FT8 or Whisper or whatever, where I get the audio over the USB card and I measure the frequency of the audio that's coming in by counting the time between 0 crossings. And then I add that frequency, for example, 1000 Hertz, to the USB dial frequency and synthesize directly using the 53551A at the transmit frequency. It results in a very clean transmission because there's 0 unwanted sideband, 0 carrier. It's just a perfect transmission for FSK modes, much more clean than if you use an SSB transceiver. So that was a kind of unique thing about it. And having the built-in USB sound card, it gives you a perfect audio between your PC and your radio. There's no loss, there's no distortion, there's no hum. WSJTX or whatever Digimode software you're using generates its samples to make the sine wave, and they come directly as numbers into the radio. So you get real perfection, as well as, a lot of convenience, because you don't have to have a noisy sound card on a mother card or on a motherboard or a plug-in USB sound device. It's all in the radio itself. So QDX, just like QMX, implements a superhet actually with a 12 kilohertz intermediate frequency, and everything is done with really high performance parts like the ADC chip that we use. And then I also had this terminal interface, so you can connect PuTTY to it or any other terminal emulator on a PC, because it has a virtual COM serial port. So you can, and that's used for cat control or for running these terminal tools. And that allows you to run all of these internal test tools. So it's got a signal generator you can inject in the front end, and you can run this is a 7-meter example. And you can see here that the actual peak is around 6.2, something like that. So you would then say, oh, that's a bit low. I need to expand my turns on the bandpass filter, toroid, to lower the inductance and move the resonance up a bit. And so you can use those built-in tools to do all the optimization of the filters. And then in 2023, I decided I was going to marry QDX and QCX Mini to make QMX, which was the multi-band. M was for marriage originally in my mind, QMX, between QDX and QCX Mini. You see, I've got this whole Q code robbing thing. And that originally covered 80 to 20 meters and did CW and digital modes. And that was the original plan. And this is what it came out as, in exactly the same size enclosure as the Q6 Mini. So it's only 92 millimeters wide here, a very small handheld unit, but it has massive amount of stuff packed into it. And as I said, the Q6 mini mechanical design, and then the QDX electrical design with the SDR, but then adding the LCD buttons and encoder and the connectors from the Q6 mini. And that's what became QMX. Now that was launched in May last year, and we're up over 6,000 sales of those in that time. So it's, again, a very surprisingly successful product. And this has a USB-C connector on the panel, which replaces the Q6 Mini's serial jack, which was a stereo connector. And the USB gives you again, like the QDX, the built-in 24-bit sound card and the serial COM port. And it also lets you do a firmware update very, very conveniently and easily. There's a picture of how it looks, the main board. These two connectors here are where you plug in the power supply boards, which I'm going to talk about in a moment. There's a picture with the power supply boards plugged in and the controls board. And it all slots in very neatly. I don't know if any of you have built one, but it's very neat the way it all fits together into the enclosure. But quite a fiddle to squeeze it all in. You've got to be very careful and accurate about the construction. How am I doing for time? So it's all on a 6-layer board. This is a picture of the board, and you snap it apart into the different boards that you then populate with parts and install in the enclosure. This is a picture of how the boards are separated out. There was a bit of spare space which I made into this key fob with the QRP Labs logo on both sides. So you can be a proper QRP Labs fan. Close up of the power supply boards. And this is a picture of all the components you have to install if you build the kit. So it's, capacitors, toroids, the diodes, inductors, and mostly connectors and controls. This is just a note about the six-layer board. Because the microcontroller is a 100-pin QFP chip, it turns out, and I needed it all to be compact. My target from the beginning, because I said it was marriage of QDX and Q6 Mini, I wanted it to be in that small enclosure of the Q6 Mini. So I was determined to make it fit on that board, and I had to put more layers on the PCB to make that happen. Again, just a summary of how QDX and became QMX. So a little bit about the microcontroller. I love these STM32 series of processors from ST Micro. They're inexpensive and they're very powerful, but you've got a whole family of products which you can move up or down depending on what speed you need, how much flash memory you need, what peripherals you need. And the one I chose here for this has 512K of flash and 128K of RAM. We don't use a fraction of that at the moment. It's probably about 1/3 utilized. So there's plenty of space for future expansions. The buttons and encoders are very similar to Q6 Mini, but now has 2 rotary encoders. So instead of a potentiometer, it has a volume control, which is also digital because the whole thing is digital. I also kept the digital outputs in stereo from the transceiver. So later I'll be able to do things like binaural reception or balancing between the left and the right ears if people have got hearing deficiency in one side. So I kept those separate with 2 separate amplifiers driving left and right. It also has an SWR bridge built in and SWR protection threshold. So you can set it up and it checks the SWR 1,000 times every second. So as the CW envelope or the SSB envelope comes up, if it starts to see a bad SWR, it shuts it down before it can do any damage. And that's all on a single binocular form, which is near the BNC connector. Very special feature here was the SMPS supplies that I designed for this. And the problem when you do SDR is that the microcontroller is hungry. It needs a lot of current to operate. You know this, Farhan, right? Because of the SBITX processors running fast doing SDR, they use a lot of current. And so you'd like to use switching power supplies because the QMX used about 220 milliamps if it's on a linear power supply. But as soon as I release it and I say, look, this is the same size as the mountain topper or whatever, and they all have current consumption in the range 50 to 100 milliamps, or the KX2, I think, is 150 milliamps, and this is much more, it doesn't look very good. So people care about, for portable operation, having low current. So you want to use switch mode power supplies. The problem is that they can be noisy because they're switching. So I developed my own switch mode power supply, which is basically a discrete component circuit rather than using chips, because this was also designed in the chip crisis where it was hard to get things. And so I didn't want to rely on any single manufacturer switching chip, which could go out of production and leave me in trouble. So instead, using discrete components was a very nice way to handle it. And the unique feature is that the microcontroller is part of the control loop for the regulator. And what that means is you can control the noise. So SMPSs can be noisy because they're sharp switching on-off action. And you need it to be sharper because it's that between the two states where the inefficiency becomes. So to make it efficient, you make it sharp, but then it generates harmonics forever. And most of the chips have RC oscillators, so they're free running and they've got huge phase noise. And if you've got a PC power supply, you tune across and you find these big bands of noise every 50 kilohertz, which sort of drift up and down, and it's a horrible mess. Very hard to filter out. So what I did was, because the microcontroller generates the pulse width modulation and it knows the operating frequency, I made it so that the operating frequency could be adjusted by the microcontroller so the harmonics don't come near the operating frequency. So it's quite neat. And this is an example of how it works in practice. So the top half of the screen is WSJHX on the FT8 band. There was the harmonic of the switching regulator came here. So you see it generates some noise, right? Not a huge band of noise. When I moved up 3 kilohertz to 14074, it's already clean. So it's quite a narrow band of noise, but you can definitely see it there. And then if I control the PWM frequency to move it away, that same frequency, 14071, is now completely clear. So that's an example of how powerful it is in reducing those birdies. But of course, you have a chicken and egg problem because the microcontroller is part of the control loop for the regulator, but it's also powered by the regulator. So it's all a bit incestuous. And the solution was this linear regulator, which is used initially at power up and then it switches over to the buck converter when it's ready to operate. That's a diagram of the scope traces. In this period at the beginning, it's ramping up the power supplies, and then at this point, it switches over to the switching regulator. So it really works quite nicely in practice. It also has reverse polarity protection and soft power switch. So the left encoder button, you press it to turn the radio on and then press it again to turn it off. So there's no toggle switch or anything. It's a soft on-off switch. And the advantage of that is also that when you switch off, you can, the radio is able to save its state to EEPROM. So next time when you switch on, you're on the same mode, operating frequency, volume, everything's the same as you left it. Sorry things have got trimmed off a bit. It doesn't seem to have completely compatible with your system and mine. There's an example of duty cycle versus supply voltage. I'm trying to go a bit quickly here because I'm conscious that Steve's going to beat me up in a moment. And in practice, the received current comes out between about 80 and 90 milliamps with a 12-volt supply, which is a really, really good result. And as I said, the Elecraft KX3, they talk about 150 milliamps being low. So it's a really nice result. Elecraft KX3 I talk about because they also do a similar SDR, baseband SDR and DSP to do the demodulation. I also have this envelope shaping circuit for CW envelope shaping, which came originally from the 5-watt PA kit. And that gives us a very nice, it's actually not raised cosine, it's Blackman-Harris, the shaping, which is a little bit better than raised cosine, cleaner. This amplitude modulation circuit, again from discrete components rather than the power op-amp or something like that, turns out to have a very linear control range and about 37 dB of power control range. I'm also now working on SSB on the QMX, and it has been designed with that capability in mind, with a built-in microphone on it. And it will do SSB in the same way that USDX, the micro SDX transceiver, did it by envelope elimination and restoration, which is a technique where you take the SSB and you do a Hilbert transform to get a 90-degree phase shifted version. And then you take the magnitude and the phase, so you've got an angle and a phase separately, and you do the amplitude modulation and the phase modulation separately. And the advantage is you don't need a linear amplifier. So my amplifier in QMX is a non-linear amplifier, Class D switching amplifier, very efficient, but not linear. So this is my current focus to get SSB working on QMX. There was also a comparison. So USDX, the SSB performance is not great. They were very limited by the CPU that they used and the capabilities in the hardware. The QMX hopefully will do a lot better because it has a very high performance processor and a very linear amplitude modulator. In fact, I say hopefully, but I have now two-tone testing working, but it has about 32 dBc IMD3, which is a good number. This is an example of the filter in QMX versus QCX. So QCX being analog is this blue curve. The QMX is DSP filtering, so it's got quite sharp edges. Since then, a couple of months ago, it's now got multiple filters, so you can select a bandwidth from anywhere from 50 hertz to 500 hertz in steps of 50 hertz. There are my first QSOs, FT8 for testing. Prices of the QMX, I've got all, by the way, I have some QMX downstairs and some QMX Plus downstairs. And then this year, this is the last point I will talk about, so stay cool over there. QMX Plus is like QCX Plus was. It's the same size enclosure as QCX Plus. So it's 106 millimeters by 55 millimeters high front panel, and it goes back about 15 centimeters. And QMX Plus is the same features, performance, firmware, everything as QMX, but it's in the bigger enclosure. So it's easier to build. There's more space that you can do modifications. And it has 160 meters to 6 meters band coverage. So I was able to double, because I've got lots of space for toroids, I was able to double the number of filters and the number of bands it will cover. It also has a real-time clock internally, which has a CR2032 coin cell for backup, which was not on the original QMX. And it has this optional internal GPS module with the same active patch antenna, which I have on my other GPS product, QLG2. And this is a tiny, less than an inch square GPS module, which fits inside QMX Plus near the back, near the BNC RF connector. And that gives you precise timing if you want to do whisper transmissions, because it also contains the whisper beacon feature. Picture of the rear panel there. And then there's also a dev kit, which I have. And the dev kit is just an empty circuit board with a matrix of holes where you can just build your own stuff. And you could put a Raspberry Pi in there and do remote operation. You could put battery, you could put a tuner. A lot of people have, even though this has only been available since May this year in Dayton, a lot of people have been using tuners, batteries. There are all sorts of modifications people have done already. There's also these 11 GPIO pins, which are connected via pin headers, if you wish. And in the future, I will implement a basic programming language as a scripting tool that lets people control those I/O and control whatever else peripherals they install on the top. There's the kit price for the QMX Plus. I'm not sure, did I update these prices with current exchange rates? I think I did. And we also have the assembly service, as I mentioned. And here is almost come to the end. Something about how to find QRP Labs online. Our website, QRP Labs, and we have the shop on there as well. We have a very active forum with 8,500 members, which is the only way I survive, because if there are problems, a lot of them get handled on the forum and people help me on there. You imagine it's just one of me, but there are thousands of the customers and or constructors building the kits. And then also have a YouTube channel. This is one of my favorite videos with Hannes DL9 SCO, who's the founder of Palm Radio Keys, who visited me for a week in May last year. And we went to the top of a nearby mountain in Turkey with the original QMX prototype. And we spent the whole afternoon sitting under the sunshine, under an olive tree as shadow. And just, we worked about 10 countries between us. It was great fun. There is a summary of the transceivers. And again, it hasn't come out terribly well. Something's got hidden here, but I've got some prices on there for the kits. The kits are all very, very low price and very high performance and good value for the price. So that's the end of the video. I think I actually did manage it in 37 minutes. That's not bad. Sorry, it was a bit quick, and depends on the talk and what the venue is and how much time we have in more detail. But any questions we can deal with, or if we can't finish here, I'll be downstairs.
I'm going to say I'm just going to be downstairs in the hall for obviously for the people online. That's not really a good option, but for the people here today, that would be fantastic. Are there any questions, Martin? None online. Any questions in the room? Come on, Dom, you'll need to shout from there. My microphone won't reach.
That's right. Hans, in the QDX, so QMX, you've got the A5532.
Yeah.
Why did you choose that out?
Because I've always used that op amp is inexpensive. It's got a reasonable low impedance output. And a lot of these things you can't always determine from the data sheets. Unfortunately, you read the data sheet and it gives you some typical specifications, some applications, but I'm using here an op amp as the driver for the earphones. And we had found, going back to QCX Mini, some op amps work in that application and some don't. And I had found, I've used 5532s going back decades, and it's kind of just one of my personal favorites. It's available, it's inexpensive, it's quite high performance, not amazingly high, but quite high. We use a much higher performance, LT6231, for the preamplifier for the ADC in the receiver. So yeah, the main reason was just that it's one of my favorites. It works well. It has good availability. What's not to like? For the 5532? No, I mean, I just run it with single rail and it works fine. Yeah.
Any more questions in the room? Right here at the front.
I noticed you're still using the BS170s.
Yeah.
With all the sort of mobile phone FETs and transistors that are around now. Have you considered sort of moving over to one of those that would give you probably more power than for BS170?
It's a really interesting question. It comes up a lot on our forum. People have suggestions about better MOSFETs. The things about MOSFETs is there's no magic. But you can, if you look at all the characteristics of MOSFETs, all the MOSFETs available, and you plot them on a two-dimensional space, for example, with power dissipation or input capacitance, however you look at it, they all cluster around a trend line. And you choose what point on that trend line is going to be suitable for what you want. And it turns out the reason I love the BS170s is because they're dirt cheap. They're available all over the place. There's never any availability issue. And they're perfect for a 5-watt transceiver. If you go to a bigger transistor that has higher dissipation or higher current handling capability, you inevitably look at the capacitance specifications and the capacitance went up. And then it gets harder to drive efficiently, or it gets harder when it goes to higher frequencies. It will be okay at the bottom end of the frequency at HF, but when you go up to 6 meters, it gets very hard to drive higher capacitances. And so there have been various suggestions on our forum, and when you test them, you inevitably find it works well on lower frequencies, but when you get higher up in frequency, the efficiency and the power output both drop. There's also the fact that BS170 is a through-hole component, so it's easy for people to replace. A lot of people don't want to do any SMD, and a lot of the new transistors that you're talking about are only in SMD. And so for now, I think it's still the best transistor. And we've used hundreds of thousands of these since Ultimate 3S for the last decade. There's a certain, it goes back to what Don said as well, when you have a part that works, it's risky to change to another because all sorts of unexpected things happen and it gets very expensive very quickly when things go wrong. So there's kind of a comfort factor staying with what you know.
Also just had a saying beamed into my head from somewhere that's it's vain to do with more what can be done with less.
You're right.
So folks,
Just got one question from the listeners. So Ian, M0WJI, I would like to know, so given it's your focus, when will SSB be available on the QRP?
I learned some time ago not to put dates on things. But I did make very good progress recently on it. It's been my focus. March, April, June is very busy because of Dayton, then Friedrichshafen, and then catching up from those. but I have been working on it in the last few weeks, and I have it going very nicely with two-tone generation, and it's producing a really good IMD3 performance. So hopefully over the next coming weeks, I'll get that finished off. It is the #1 focus. There were a lot of things in the last year, like there was glitches on the CW keying, semi-QSK wasn't working, there were thumps on transmit, receive, handover. There were all these things that demanded attention and had to be fixed because people were screaming about. Now everyone's screaming about SSB, so that's kind of top of the list.
Excellent. But I'd love to stay here and let more questions flow, but so Hans is going to be downstairs. If you want to go and have a chat with him, I'm sure he will answer any questions you've got. But before we clear the room, please.
Yeah.
Thank you very much. Thank you.